Hello class, welcome back to another lecture. This one is about groups in the periodic table. So let's get started. The first thing is we're just going to go through some basic things about the periodic table. What we've learned so far is just where our different groups of metals, nonmetals, and metalloids are. So let's start by going through some other important basics. Columns, every column in the table is called a, sorry about that, I just forgot to underline. Our columns are called families or groups. So that's also, again, another good reminder that anything underlined is really important for us to remember. So make sure we're writing those notes down in your own notebook. But every column has very similar properties. So every element going from the top to bottom column is this very similar, and we'll get into why. They all have the same number of valence electrons, is that reason. So last lecture we learned about valence electrons and their definition. They're the electrons in the outermost shell of our elements, and they are the ones that are actually most involved in our chemistry. So most of our chemistry happens with those valence electrons. The other part of the table is our rows. So those are called our periods. And each period, every element in that period has the same number of electron shells. So we'll describe that a little bit more coming up. But the first thing we're going to talk about is groups. So we have 6 major groups. Our first group is our alkali metals here on the far left. That is group 1. It can be numbered 1 or 1A. I'll explain those in a second. Then we have our alkaline earth metals. So we have our alkali metals. Alkali earth metals is our second group. Then we have our transition metals, which is a big chunk of our table in the middle where most of our metals are. We have our inner transitional metals as well. So every one of these has metal in the name, which we learned last time when we were describing the difference between metals, nonmetals, and metalloids. So inner transition metals are the ones down below. And then we have these four that are the boron, carbon, nitrogen, and oxygen family. Those names aren't as important for us to remember. And then we get to halogens. Halogens are very important, and so are noble gases. So let's explain some of this numbering real fast. So we have actually 18 total columns. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. So 18 total. Now, each one, if we wanted to just look at valence electrons, we would look at the A's. So 1A, 2A, 3A, 4A, 5A, 6A, 7A, and 8A tell us the valence electrons in each of these, which is what's really important for our chemistry. So 1A means that all of these alkali metals have just one valence electron. Same for 2A, the alkaline earth metals all have 2 electrons. The boron family has 3 valence electrons. The carbon family has 4 valence electrons. The nitrogen has 5 valence electrons, 6 for the oxygen family, 7 valence electrons for the halogen, and then 8 valence electrons for the noble gases. So 8 is the most we can have, but that is a little bit more detail on our periodic table. So let's talk about families or groups and groups. So our groups, we have our groups. They're numbered 1 through 18, or 1A through 8A, like I just described. Our first one is called the alkaline metals, and we're going to describe them a little bit more. So what are the characteristics? This is really important for us to know, is how the characteristics are different for each one. So they are less dense than other metals. They have one loosely bound valence electron. Let me update that. Sorry about that. Just had to add they have one loosely bound valence electron. And then an important thing to know about them is that they are highly reactive. Because they just have one valence electron, it is very easy for them to give that electron up and react with other atoms and elements. So group number 2, or 2A, is known as the, again, are known as the alkaline earth metals. And what's specific about them is they have 2 valence electrons, and they form divalent cations. So a divalent just means 2 valent. So di is 2, valent is our valence electrons, and then a cation is a fancy word for a positive ion. So they will give up their electrons to become more positive. Our third group, or I should say really groups, is groups 3 through 12. These are our transition metals. They're easy to form in wires or anything else. They're really malleable. So that just means that we can use them in our for lighting, or maybe if we wanted to make a bed or something. They're easy to use. They have high melting and boiling points, and they have a high thermal and electrical conductivity. So we talked about metals having high thermal and electrical conductivity, and transition metals especially. So our next group is group 17, or 7A, which are halogens on the far right side of the table. These guys have 7 valence electrons, which makes them extremely reactive as well. So they like to steal electrons, because if we have 8 electrons, we're in a very stable place. So the atoms and elements really like to get to be stable, so they'll take electrons easily, usually from our alkali metals. So our alkali metals and halogens usually react together. Our last one is group 18, or 8A, which are noble gases. These are very stable because they have a full shell of electron. Their outer valence shell is complete, so they are no longer looking to gain or to lose electrons, because all valence electrons are present. So this is a really important slide. I encourage you guys to look through it and read through it a couple times. But we'll explain a little bit of why. Why do each of these atoms act so similarly when they're very different in size? And it's all around their valence electrons. So each group has the same number of valence electrons in it. Group 1 has 1 valence electron. Group 2 has 2 valence electrons, as I've said. So our example here is we have sodium, potassium, and rubidium, which all have 1 valence electron because they're all in the alkali metals group. As we can see, each one has different shells. So our first shell for all of them has 2 electrons. 2 electrons. The next one has 8 electrons. And then we get to our valence shell in sodium, which just has 1. If we're in potassium, we have another 8 electrons before we get to our valence shell, which is just 1. In rubidium, we get into our transition metals. So there's actually 18 electrons in this shell before we go back to 8 electrons and then our 1 valence shell. So all these electrons on the inside that have a full shell really do not change the reaction at all. It's what matters is this extra valence that we can see here, here, and here. Regardless of the size, all 3 of these still want to get rid of this 1 valence electron so that they can be stable. So let's classify some of these elements after we've learned where they are, and maybe talk about their characteristics. So what group is iron, which is abbreviated Fe in? So if I'm looking for iron, I find it at number 26 right here, which is in our transition metals. We even have a nice color-coded area for I guess example or a key to learn. So all our transition metals are this color. And our transition metals, if we can remember, are highly thermally and electrically conductive. What group is bromide in? Br. So if we're looking, bromide is over here on the right side, number 35. And if we look at our list here, it doesn't have halogens. Interesting. It calls it a reactive nonmetal, but what we're going to do is call just this last row a halogen. Oh, we can see it up here even. Halogens. Perfect. Halogens. And halogens are very reactive because they want to gain one more electron to get to 8 valence electrons. What group is magnesium in? So magnesium is Mg. We find it at number 12, and that is alkali earth metals. So alkali earth metals like to give up both of their valence electrons. They're in group 2, so they have 2 valence electrons, and they like to give that up so that they can be stable as well. And then I think our last one is helium. Helium is He, and it's over here on the far right on the top corner. It has a full shell of 2 valence electrons. Helium and hydrogen are a little different than the others, but it is a completely stable gas because it has a full group of electrons, so it is known as the noble gas group. So that is all I have for you guys today. I encourage you to maybe look through this periodic table and the one at the beginning of the lecture that had all our nice letters, and just familiarize yourself with where each type or group is, and then also their characteristics. So if you have any questions, let me know. Thank you.